Alrighty, 1.3, naming polynomials. So starting off, what is a polynomial? A polynomial is an expression consisting of numeric, algebraic, or a sum or difference of numerical and algebraic terms. Right. Numeric, what does that mean? That means a number. That means a number. Algebraic, that means a variable, right? So like x. It tells us that all exponents are whole numbers and no variable is present in the denominator. So that means in different terms, it would mean that the exponents can't be negative, right? Because if you had x to the negative 1, that would be 1 over x, and the x would be in the denominator, okay? So we can have a string of numbers, or a string of numbers and variables, so maybe like 5x squared plus 2x plus 3. That would be a polynomial, right? All the exponents are in the numerator, and they all have whole number exponents. Another example would be like 5x, right? That's a much shorter one, but it still works. The number 5, or maybe I'll use a different number. We'll use the number 6. Just a plain old 6. That would be a polynomial as well. 20x to the 50th. That would be one. Nice short one. You could do 20x to the 50th plus 3, right? You can add those things on the end. And lastly, just a plain old x would be a polynomial as well. So before, you guys have graphed y equals x. So from here we can say that y equals x is a polynomial. It's a simple polynomial, but it is a polynomial. Non-examples of polynomials. Square root of x, 1 over x, x to the 5 halves. Okay. Anything that has a x or a variable in the denominator, or a fractional exponent, or a root. Additionally, for the examples of polynomials, you could have like 2.5x. That's okay. It's okay if the number in front is not a whole number, but the exponent of the x has to be a positive whole number. All right, let's go on. Within the realm of polynomials, just like how whenever we would name shapes, we had all kinds of different names for the shapes. We have different words here. A monomial is a polynomial of one term. That means there's no pluses or minuses, right? So a monomial could be just a plain old x. Okay. It could also be negative x, but it could not be 1 minus x. It couldn't be that. A binomial is a polynomial with two terms. So there's two things listed. So this could be like x plus 3. It could be 2x plus 5. It could be 5 plus 2x, right? A lot of the times, whenever we would have lines, they would fall into the monomial or binomial, right? Depending on if they were shifted up or down. A trinomial is a polynomial with three terms. So this would be like x squared plus 2x plus 3. Or maybe it could be x to the 5th plus 2x plus 1. Right, that would work too. There are more words for describing the 4th and 5th, but what we're going to do is we're just going to refer to them as a polynomial. So there at the bottom in italics, you can see that it says if a polynomial has more than 3 terms, we just refer to it as a polynomial. We don't have a special word for it, okay? If you go online, there are some special words, but for what we're doing, we only need those 3. All right, the degree of a polynomial. So up here, we count how many terms there are. We count how many things are between pluses or minuses. Down here, we describe the exponent. So the degree of a polynomial is the sum of the exponents of the term in the highest sum, the sum of the exponents of the term with the highest sum of exponents in the polynomial. That's really hard to see. It's the biggest exponent. That's what that means. The biggest exponent. The biggest exponent, okay? So we look here, we have degree 0, That means there's no variable. So we just have a plain old number. It's called a constant. Degree 1 is described as a linear. So this would be like 5x plus 4. And you could probably recognize that as being a line. Degree 2 is called quadratic. So that has an x squared. Degree 3 is cubic with an x cubed. Degree 4 is quartic, x to the fourth. And degree 5 is quintic, x to the fifth. The standard form of a polynomial is whenever you write it in order. So the highest exponent goes first. So we'll look here and let's look at the degree 2 one here. We see that it goes biggest exponent, x squared, and then an x, and then no variable. Right? The cubic has the cubed, and then the squared, and then it just goes dot, dot, dot. You put the biggest exponent first. So that's what standard form is. The leading coefficient is when it's in standard form, what is the first number that you see? So back in our degree 2 example, the first number we see there is a 2. That's our leading coefficient, right? This 2 here, that's the leading coefficient. All right, our examples is write each of the following polynomials in standard form, then classify each by degree and a number of terms. And we're supposed to circle the leading coefficient. So A, putting it in standard form means biggest exponent goes first, and at the last we have our number, our constant. So this will be 3x plus 5. Let's box the 3 to show that that's our leading coefficient. And this will be a linear binomial. Right? It's linear because the exponent of our x is a 1, and it's binomial because there's 2 terms. B, we have 15x. Well, 15x, that's already in standard form, so I'll just rewrite that. 15x, the leading coefficient is 15. This will be a linear monomial. Right? It's linear because our highest exponent is a 1. It's a monomial because there's only one term. All right, part C. This one's a little bit more complicated. We look at our biggest exponent first. So we'll have 12x to the 6th plus x cubed plus 2x plus 8. Right? I wrote it with the highest exponent first, the second highest next, and then so on. This will be a, what is a 6? What is that word? Hope we don't have that one. Whenever you have one that's higher than 5, there are words. If you go online, there are all kinds of words there. But what we're going to do is we're just going to call this a polynomial. Right? We describe it as a polynomial because it has more than 3 terms. Polynomial of degree 6. Right? If this were to not have this 8, if it were to be only 3 terms, we would call it a trinomial because it has 3 of degree 6. Okay? But since it has the 4, we're going to call it a polynomial. D, we have x cubed plus x squared plus 2x plus 3. So this will again be a polynomial. But this is an x cubed, so that's a cubic, so cubic. So it'll be a cubic polynomial. X to the 5th. So this is just x to the 5th. And so what is the 5 number? It's quintic. So we're going to call this a quintic monomial. Right? Lastly, we have F. We just have the plain old 0. This is a constant monomial. And I forgot to circle the leading terms, so let's go back and do that. Let's look at our number C first. The leading term here is 12. The leading term for D is actually going to be a 1, right? So it's a 1x cubed. For E, the same thing. We have a 1 here. And for F, it's just going to be 0. All right. Hopefully that's not too crazy. Just so we know, the words that we will most often use, we really won't use the 4 or the 5. Pretty well after we get done describing them, they won't be used very much. Okay. The constant, linear, quadratic, and cubic will be used often, especially the words linear and quadratic. Those will be used a lot. Next chapter, we'll get into quadratic equations and how to graph them. So, all right, that's all.